Hello everyone, welcome back to my additional math channel. For today's video teaching lesson, I will stay focused to one of the hot questions involving rate of change. So please focus to the video teaching and have fun.
Today we're going to do a related rates question, and the question says, air is being pumped into a spherical balloon at a rate of 200 centimeter cubes per second. How fast is the radius of the balloon increasing when the diameter is 1 meter? Well, I see 1 meter here, but I see centimeters there, so why don't we make the units more consistent? So the first thing I would do is I'm going to change this 1 meter into 100 centimeters. You know 1 meter is 100 centimeters. Alright? Okay, so everything's in centimeter, that's good. Now the next thing I need to do is, well, what is this 100 centimeters? It's the diameter, right? So that means the diameter, let's call this D for diameter, is 100 centimeters. If the diameter is 100 centimeters, then what's the radius? Radius is going to be half of that, right? So that's going to be 50 centimeters. And what is this question telling us as well? It tells us that the air is being pumped into a spherical balloon at a rate of 200 centimeter cube per second. What is this 200 centimeter cube per second? Well, it's in cube, right? So you kind of think it's, okay, it's volume. But it's per second, and it's talking about at a rate of. So it's not just volume, it's actually the volume, the rate of change of the volume in terms of time. So this is dV over dt. And dV over dt tells me this is 200 centimeter cube per second. All right. Do we know anything else? Doesn't look like it, so I think that's okay. But what are we looking for? That's the question. It's telling me how fast, or it's asking me how fast is the radius of the balloon increasing? The rate, right? How fast? How fast means it's the rate. So it's saying what is the rate of the radius of the balloon? So it's not just the radius, it's the rate of the radius. So that means we're looking for dr over dt. What is this? We need to look for. So we have this information, but we need this information. So why don't we, I'm just going to put a box around it. So why don't we try looking for that? Because that's what we want. Okay, good. But okay, I have everything I want, but I'm missing this thing which I need to look for. But how do I actually picture this? It's always good to draw a picture in these questions. So air is being pumped into a spherical balloon, right? So how do I picture this? Well, if let's say I have this tiny little thing, okay, and then there's this thing that is some tube. And then every time I pump on this thing or press on this thing, air goes into the balloon, the spherical balloon. So how do I draw this spherical balloon? I'm not a very good artist, I'll try my best, but it probably looks something, I don't know, let's say the sphere looks like this. Oh my goodness, it looks terrible already. And it's a spherical balloon, it's not just a circle, so probably something like this. Imagine an egg, I guess. Looks like an egg, but not a balloon. Anyways, it's a sphere. So we got the idea. And it's telling me that, all right, the radius is 50 centimeters. Okay, so we kind of got a good picture, right? And remember, the balloon is increasing, right? It's expanding because air is being pumped into it. So I'm going to draw a bunch of arrows like this. And what this is telling me is that the balloon is being expanding, so it becomes bigger and bigger. So what do you see as you see this balloon gets bigger and bigger? That means the volume is going to get bigger, and that means the radius is going to also get bigger. So we kind of have the idea there. So that's pretty good. Okay, what do we need to do next? Again, we're still looking for dr over dt, right? Well, we're given volume, right? Wouldn't it be a good idea to use the volume formula? What is the volume formula for a sphere? In fact, I think I forgot. Actually, no, I didn't forget. It's this. 4 over 3 times pi, so pi, r to the power of 3. That is the formula for the sphere. And we're going to use this formula. Alright, so we kind of have the idea for the picture. Feel free to draw or pause the video and draw the picture, so then you can, follow with me so that you understand the picture more. I'm just going to erase it. And I want to use this formula, right? Okay. Since we have dv over dt, why don't we take this and take the derivative? We're not just taking the derivative, but we're taking the derivative in terms of time. So everything's over dt. So if I take the derivative of this, I have dt, or dv over dt. And this is equal to 4 over 3 in the power, just constants, so I can leave them there. We do the power rule and we bring the 3 down. And we minus the exponent by 1. So this is r squared. And then we got to do the chain rule. And the chain rule tells us that we have to times this by dr over dt. Because the chain rule of the radius is the radius in terms of time. Like that. Now, why is this useful? Why do we need to use this? Look at this. We'll check this out. We know what dv over dt is, right? We know it's 200. And we know what r is, and r is 50, right? So if we plug those two in, what are we going to get? We're going to get 200 is equal to 4 over 3 pi. I'll do this in blue so you can see what I'm doing here. I'm plugging it in. So 4 over 3 pi times 3. And if you plug this in, this is going to be, radius is 50, so this is 50. And this is being squared. And times by what? dr over dt. Isn't that what we're looking for? We're looking for it. Look at this. We have everything here. And we have dr over dt there. So if we have everything here, we can just solve for this equation and just figure out what dr over dt is. Okay, good. So why don't we do some arithmetic? So here 200 is equal to 3 over 3, you can see here is just going to cancel out, so I'll just cancel out the 3's here. So this is just going to be 4 pi. 50 squared is 2050. 2050, what am I saying? 2500 And this is times by dr over dt. Okay. Looks pretty good. And then, now see everything here? I'm just going to divide both sides by this ugly mess. 4 times 2,500 is 10,000. So I'm just going to divide this by 10,000 pi, or in this case, 4 times 2,500 times pi. And divide this side by 4 times 2,500 and pi. And so this whole thing here cancels out, and we just have dr over dt left, so that means dr over dt is equal to 200 over 4 times 2,500 times pi. And to simplify this, I don't know. So this is just 200 over 10,000 pi. And this is just the same thing as, cancel out the zeros. So cancel out the zeros, there's 2 zeros here, you can cancel out the 2 zeros here. This is just going to be, so this we have 2 over 100, so that's the same thing as 1 over 50. So 1 over 50 pi. Perfect. So that means dr over dt, or the rate of the balloon, is 1 over 50 pi. What are the units? The units are in centimeter per second. So this is centimeters per second. So the answer to this question is, well, how fast is the radius of the balloon increasing when the diameter is 1 meter? It's increasing at a rate of 1 over 50 pi centimeters per second. Thank you for watching.
Thank you for teaching my student. So I think after you attend the video teaching, you should be able to solve the question involving rate of change. So till then, I shall see you in my next video lesson. Bye bye and have a nice day.